All right, welcome back. Now it's time to talk about composition of functions. This is another way to combine two functions. It's a little bit more novel than the other ways that we had previously combined them in the last video. So the composition f of g of x, that's how this is read. This little circle here, you can read it as f of g. And now because I don't really like that this circle kind of confuses me with multiplication, I like to really just kind of write it exactly as it's kind of meant. So f of g of x is written, and my notation would be you write f outside and you take f of g of x. Okay, it's kind of like this nesting of functions here. And what's the idea is that you take the expression that you have for f of x, say it's something like, 3x plus 1 or something like that, and everywhere that you see an x, you replace x with g of x, which is going to be some other function. For this to make sense, though, you first need that the outputs of g, the range of g, need to be in the domain of f. So the kind of classic picture that they like to draw for this is that here's the domain of g, all the x values that are admissible for g. And then you g them and take those x values to g of x. And the range of g, all those g of x values, needs to be inside the domain of f. And then from there, you can take f of just those g of x's. And that will take you somewhere into the range of f. Okay, so let's try it here. Let f of x be x to the fourth minus 4x plus 1. And let g of x equal to x plus 2. So first, they ask us to find f of g of 3. So the inside function here is g of x, so we'll do g of 3 first. And what do we get? G of 3 is 3 plus 2, which is 5. Now, f of g of 3 is going to be f of 5, because we evaluated g of 3 to get 5. And so f of 5 is 5 squared minus 4 times 5 plus 1. That's 25 minus 20 plus 1, which I believe is 6. OK, we could go backwards sometimes. Not all the time, but this time we can. So g of f now, let f be the inside function. So we'll find g of f of minus 4. So first, the inside function is now f, so we'll evaluate f of minus 4. We get minus 4 all squared minus 4 times minus 4 plus 1. I believe that gives us 16 plus 1, which is 33. And now we'll evaluate g of f of minus 4 is really just g of 33, because we found f of minus 4, that was 33. And g of 33 will be 33 plus 2, which is 35. OK, so not so bad. Now let's do maybe a general one and look at what's going on with the domain. So f of x will be 3x minus 12. And g of x is 1 over x plus 2. We will find f of g of x, and then we will find the domain. Note, to be in the domain of g of x, you first need to f of g of x. You need to definitely be in the domain of g of x, because we need to do g of u first, right? But there might be some that we might exclude after the fact. Maybe. I don't know if that's going to happen in this case. So we have here f of g of x. Well, I'd like to write it like this, f of g of x. And I like to say, take the expression that you have for f of x, and everywhere you see an x, replace it with g of x, so that f of g of x is 3 times g of x minus 12. OK, now we'll take the expression that we have here and replace g of x with what we know to be the formula for g of x. So namely, 3 times g of x minus 12 becomes 3 times 1 over x plus 2 minus 12. And then we can simplify this first one here to be just 3 over x minus 2 minus 12. And to find the domain, well, let's see. Is there something wrong here? Can something go wrong? Well, I think we would divide by 0 if x was minus 2. So we can't have x equal to minus 2. But I think every other x value is going to be just fine for us here. So the domain is the set of x from -infinity to -2, not including -2, and then union with the interval from -2 to infinity, again, not including -2. Okay, let's go backwards. Let's see if that one works backwards. Can we find g of f of x in its domain? So f will be the inside function now. And so we'll take the expression for g of x, and everywhere we see an x in the expression for g of x, we'll replace it with this new guy, f of x first. So in particular, the expression for g of x is 1 over x plus 2. So g of f of x will become 1 over f of x plus 2. And now we'll go back and remember that the function f of x was equal to 3x minus 12. And so we'll put that in now for f of x. So we get 1 over 3x minus 12 plus 2. This comes down to 1 over 3x minus 10. So now to compute the domain of this one, we need to see, oh, OK, well, was there any issues about the domain of f to begin with? F, I think, allowed all x in its domain, because we could take any x and multiply it by 3 and subtract 12, and we'll get an honest, real number. So there were no issues with the domain of f, but there are some issues with the output at the end. So namely, we have 1 over 3x minus 10. We cannot have that 3x minus 10 equals to 0. That is bad. We do not want to divide by 0. So 3x minus 10 cannot be equal to 0, means that x cannot be equal to 10 divided by 3. So that is the only value that is not allowed here. So our domain is the interval from -infinity to 10 over 3, union with the interval from 10 over 3 to infinity. OK, then they ask us an even weirder one. They say, find f of x. That's like taking f and repeating it. You take an x value, you f that, and then you f that again. OK, well, so let's see what's going on. We'll take f of x. That means we look at the formula for f of x, and everywhere we see x, we replace it with f of x. OK, so f of x is 3x minus 12. So f of x is 3 times f of x minus 12. And then we'll remember that f of x was 3x minus 12. I don't know how we could forget at this point. And so we have 3 times the quantity 3x minus 12, all minus 12. OK, well, I guess if we want to write out this one, we have 3 times 3x is 9x. And 3 times 12 is 36. So we'll get 9x minus 36, and then minus 12, which simplifies to 9x minus 48. And since the input or the inside function, f of x, had no issues with its domain, and it looks like the ending function, f of x, doesn't have any domain issues either, the domain will be all real numbers here. OK. Let's do one more here. This last one is tricky, but good. So buckle your seatbelts. So they let j of x be 1 over 2x minus 6. And k of x is the square root of x minus 7. So we will find j of k of x, and we will find its domain. But let's first just sit back and look at the domains of each function separately. So the domain of j of x is the set of all x that make 2x minus 6 not equal to 0. So that is to say that x cannot be equal to 3. That's useful for us, maybe. But what's even more useful is k of x, that inside function, the one that we do first. That one can only take in values x that make x minus 7 bigger than or equal to 0. So in other words, the only x values that we can put into the original inside function, k of x, are x bigger than or equal to 7. OK? So we'll watch out for that. I think that's going to come back and haunt us before the end of this one. So j of k of x, well, we'll take the expression that we have for j of x, and everywhere we see an x, we'll replace it with this k of x. So here we have 1 over 2 times k of x minus 6. OK, and now let's remember what k of x was. It's the square root of x minus 7. So our composition becomes 1 over 2 times the square root of x minus 7 minus 6. Okay, so to determine the domain, note we still need that x is bigger than or equal to 7. So that's going to be the, the largest possible thing that we can have for the domain is that interval. But there might be some other values that we need to exclude as well. So we'll also need that this whole denominator here is not equal to 0. So in particular, we need that 2 times the square root of 7, or sorry, 2 times the square root of x minus 7 is not equal to 6, because we do not want to divide by 0, and that's a possibility in this case. So, oh gosh, now we need to solve some equation with radicals, right? So we cannot have, if we divide both sides by 2, we cannot have that the square root of x minus 7 equals to 3. And so now let's square both sides to get rid of this radical. And we say that we cannot have x minus 7 equal to 9. Okay, and now let's add 7 to both sides. And we get that x cannot be equal to 16. So the domain of our composition is the set of x bigger than or equal to 7, but not x equals to 16. So, so in interval notation, that is the interval from 7 to 16, which includes 7 but not 16, union with the interval from 16 to infinity, again, not including 16. It looks like I kind of wrote all over the page here, and so I ran out of space for example 9, but that's okay. I think we've done enough damage here. We can talk about example 9 when we meet in class time, or if you want to email me about it, that sounds fun too. I think this one, honestly, we'll probably go back over example 8 when we meet in class too, because I think it's a pretty rich example. It's a pretty good one. So we'll see you then.